Hanji, good afternoon, student. Today I'm going to explain the concept that is various microcontrollers. Okay, so there are so many versions of the microcontrollers. So now we will deal with the specific 8051 microcontrollers, and in this we will discuss the 8751, then your 88089C51 and DS89C4X0. These all are the various 8051 microcontrollers. Okay, you can also say that this is the actually this concept tells about the overview of the 8051 family. Now we know that in 8051 microcontroller there are so many microcontrollers for that. Although the 8051 is the most popular member of the 8051 family, but 8051 is available in different memory types such as UV EEPROM, that is ultraviolet erasable programmable read-only memory version, then flash RAM version, then NVRAM, non-volatile RAM version. So, on the basis of the memory used for that, we have the various 8051 microcontrollers. Sorry. The UV EEPROM version of the 8051 is your 8751. As you can see on your screen, that 8751 microcontroller is based upon the UV EEPROM. And flash ROM is used in the 8089C51. 80 stands for your Admiral Corporation, which is the company name. Third is your using the NVRAM, and the NVRAM version for that is your DS5000. Actually, DLR Semiconductor gives us two versions of microcontroller, which one is based on the flash memory and second one is on the NVRAM, that is non-volatile random access memory. Flash version is given by the sequence by the part number, that is DS89C4X0, whereas if DLR semiconductor using the NVRAM, then the number will be DS5000. I will discuss DS5000 in the next slide. There is also one-time programmable version of 8051 is also possible, that is OTP. Now I will discuss these three versions one by one. First is 8751 microcontroller. Actually, 8751 microcontroller has only 4K bytes, means 4 kilobytes of on-chip UV EEPROM. So for using this chip, we have to access or required a PROM burner as well as UV EEPROM eraser. The program is burned by the PROM burner and it is erased by the UV EEPROM. And UV EEPROM eraser to erase the contents of UV EEPROM inside the 8751 chip, so that you can reprogram it again. As it takes the 20 minutes to erase the data, so this process is very slow. That's why we need flash memory or NVRAM versions of 8051, because it takes too much time to erase the data. So we need flash memory or NVRAM that is fast. That is faster than your UV EEPROM eraser. Now the next version is 8089C51 from Atmel Corporation. This is used in the form of flash memory. On-chip ROM is used in the form of flash memory. And so the memory can be raised in seconds as compared to 20 minutes, which was in the 8751. For this reason, 8089C51 is used in place of your 8751. Because to eliminate the waiting time needed to raise the chip, and this will speed up the process, speed up the development time. To use actually the 8089C51 to develop a microcontroller based system, it requires a ROM burner that supports the flash memory, and a separate ROM eraser is not needed in the case of 8089C51 microcontroller. In case of flash memory, we can erase the entire contents of ROM so that we can reprogram it. And this erasing of flash is done by the PROM burner. And so that separate eraser is not used, not needed in the case of your 8089C51. To eliminate the need for a PROM burner, Atmel is also, this company is also working on a version that can be programmed via the serial COM port. As you know, in our desktop or in our computer, we have the serial communication port. So that extra need for the PROM burner is not required, so that in future. So next is your DS89C4X0. X0 means it can be 410, 400, 410, 420, and so on. And this is given by DLR Semiconductor. And now it's a part of your Maxim Corporation. It uses the flash memory, and it comes with the on-chip loader for loading the program on the on-chip via the PC COM port. Means we do not need the extra PROM burner, whereas we need PROM burner in the case of 8089C51. So it also advantage over the 8089C51 that DS89C4X0 uses the PC COM port for the programming purpose. Next, in the next slide is, now you can see the various version of 8051 from Atmel, and all are the ROM flash, means ROM using the flash memory. So where C, as you can see, this is the part number various versions: 8089C51, 8089 LV51, 8089C1051, 8089C2051, and so on. Where C stands for your CMOS, complementary metal oxide semiconductor, and the ROM, RAM, input output pins, timer, interrupt, VCC, how much supply is required, then packaging means how many pins are in IC, in that IC. Particular version of microcontroller, how many pins are there. So this is the table for the versions of 8051, which is from the Atmel. So you can see almost all the versions use the 4K, 1K, 2K, different ROMs, 1K, 2K, 4K, 8K, and RAM also 64 or 128. In the case of 8089C1051, it is 64, whereas in all other versions of the microcontroller, that is 128. And input output pins are 32 and 15. Timer 2, 1, it can be 1, 2, 3 in different versions. Whereas your interrupt also 3, 6, 8 means it can be 3 in one of the version of microcontroller, then 6, 8. Then VCC is mostly 3 or 5 volt. And the packaging, that is your IC pins. It can be 20 pin or it can be 40 pin. So this is the versions of 8051 from Atmel, that is all ROM flash, that is based upon all ROM flash. In further slide, now various speeds of 8051 versions from Atmel complete. As you can see, the part number for that is 898C51, that is 12 PC, then 16 PCs and 20 PC. As you can compare with the speed, 12 means 12 megahertz, 16 PC means 16 megahertz, and 20 PC means 20 megahertz. These all are the 40 pins. And packaging is DIP, that is dual inline package, means on the both sides of IC pins will be there. And plastic, that is made of here, that particular IC is made of your plastic. Then these ICs are used for the commercial use. Next is your various versions of 8051 from DLR semiconductors, soft microcontroller. As I have already discussed with you, NVRAM version. This is the, as now you can see, this is the NVRAM version. Okay, this is the NVRAM version, and the NVRAM version you can see DAS 5008. This is means 8 means 8K ROM, then 32 30K ROM, 8K 32, and so on. And T stands for your real time clock. Real time clock means, as you can see in the daily life, if you will get your phone switch off, then if you restart it or start it, switch on, your time is never behind that. It will set internally, there will be no change in the time, it will be goes on. That means this is the real time clock. So RAM is 128, input output pins are 32, timers 2, interrupt 6, VCC 5 volt, and packaging is 40. So this is the DLR's 5000 series, and this is based on NVRAM, that is non-volatile RAM. So the on-chip ROM for the DLR semiconductor is in the form of NVRAM, and read-write capability of NVRAM, that is NV stands for non-volatile, allows the program to be loaded into the on-chip ROM, and we can load the program via the serial COM port. And NVRAM is also ability to change the ROM contents 1 byte at a time. Means all the contents will be not be erased. We can also erase the 1 byte only, which is required. And this is contrast with the UV-PROM and the flash memory, where entire content will be erased. So in that case, entire content will be erased before it is programmed again. But this is not the case with the DLS 5000 series. We can erase one byte at a time also. And the real time clock. Next is the real time clock. Generates and keeps the time of day and date even when the power is either off. So this is the real time where T in the version is written, that is real time. So this was the table for that. Now come on to the next slide. Yes. So as I have already discussed with you, DLRs, NVRAM based, RTC, that is real time clock, and the another version of the 8051 microcontroller is OTP, that is one time programmable version. Flash and NVRAM versions are typically used actually for the product development, and when a product is designed and absolutely finalized, the OTP version of 8051 is used for the mass production in that case, because it is much cheaper in terms of price per unit. So that's why OTP, that is one time programmable version of 8051, is also available. And the last 8051 family is from also Philips also. So this is the major producer also. Philips is the major producer of 8051 family also. It includes the various features like ADC, that is 8 to D converter, analog to digital, digital to analog, extended input output, and both OTP and flash versions are possible. So these were the some of the various microcontrollers, various 8051 microcontrollers. Now in the next slide we will see a table. This is the versions of 8051 from DLR semiconductor. Again, this is in the form of the NVRAM is written and speed is also mentioned. Again, T stands for RTC, that is real time clock. So the part number is DL5088. 88 means first digit 8 shows the NVRAM 8K, and second is speed, that is 8 megahertz. Now in the second case, DS5812. 8 means first 8 means NVRAM depicts the 8K NVRAM, and 12 is the 12 megahertz is the speed, and so on. So 32.8 DS5000T, 32.8 without real time clock, and with real time clock version is also possible. So 32K 12 megahertz, and 8K and 12 megahertz, and so on. These all are the various versions. Now in the next slide, these are the various versions of 8051 or 8052 microcontroller from DLR Semiconductor Maxim Corporation. So these are also the versions. ROM, RAM, input output pins, and timers, interrupts, and the VCC is mentioned. Like DS89C420 by 30, DS89C 440, 450, 5000, DS5000, and DS80C320, then DS87520. These all versions. These all versions for the microcontroller, and different ROM, RAM, input output pins, then timers, number of timers, then and number of interrupts, and VCC is mentioned. So DS80C320 is the ROM-less version. As you can see, this is UK, sorry, 0K. And also mentioned with that, the memory used, that is flash or the UEEPROM or the NVRAM. So this is the various 8051 microcontrollers. Now, after finishing this concept, now we will do the next concept, that is different types of microcontrollers. There are two types of microcontrollers. First is embedded and second is external memory microcontrollers. Embedded means everything is on the chip. And external memory. Embedded also means do only one task. And second is external memory, means memory is attached from the outside. Now the next diagram is for the embedded microcontroller. As you can see, timer, counter control, interrupt control, serial input output, parallel input output, then crystal 1, crystal 2 means frequency, then reset circuit, then VCC, ground, everything is on the chip. So they require only the power, clock and reset circuit to operate. Rest of all of the things on the chip. So this is the embedded microcontroller. Now next is external memory. As you came to know from the name that external memory, as you can see, microcontroller is there and external memory is attached. And there is address bus, data bus, address bus for the fetching the data from the external memory. Data bus is taken from the data bus is used for taking or giving the data, writing or reading the data. ALE address latch enable, and latch is used for addressing the external memory. So in large systems, the inbuilt program memory is insufficient. So the remedy for that is to connect the external memory. And the external memory is connected with the microcontroller in the given diagram, using the latch, address bus, data bus, and so on. So this was the concept of your different types of microcontroller. Now in further concept, we will do the comparison of your microprocessor and the microcontroller. Okay. Hanji, dear students, now in the last concept of this chapter, we will do the last concept, that is comparison of microcontroller and microprocessor. Okay. So these all are the some of the points which distinguish between the microprocessor and microcontroller. So first is actually a device that integrates number of useful functions into a single IC package, means everything is on the chip. That is called your microprocessor. But in case of microcontroller, okay, so means we have to use the, not all the things are on the same device. See, not in the in single chip, but in microcontroller we get all the things on a single chip, and that is inbuilt. Okay, and extra things are not to be added. But in case of microprocessor, we have to add the extra RAM, ROM, input output timer separately. But in case of your microcontroller, CPU and these CPU, RAM, ROM, input output timer, these all are on the single chip. Then designer can decide on the amount of RAM, ROM, and input output ports. But we can, but in case of microcontroller, we have fixed amount of on-chip ROM, RAM, input output ports. Then in case of microprocessor, program memory and data memory are the same. But in case of microcontroller, we use the program memory and data memory as a different. Then is microprocessor is suited for the processing information in computer systems, whereas microcontroller is used for the control of input output devices. And in case of microprocessor, we have powerful addressing mode. And in case of microcontroller, we have a compact instructions. In further chapters, we will discuss all the instructions. The microprocessor can use the data bus 8-bit, 16-bit, 32, 64, 128. Next, microcontroller also can use the data bus 8-bit, 16-bit, 32 bits wide. The clock rate is greater than 1 gigahertz. In giga, it means 10 raised to power 9. But in case of microcontroller, it is 10 to 20 megahertz. Microprocessor is used for the general purpose, whereas your microcontroller is used for the single purpose. So, if I will summarize the comparison between the microprocessor and microcontroller, actually a microprocessor is a chip that is dependent on other chips. Means we have to add other devices also. But microcontroller is your single chip. In microprocessor, we have ALU also, general purpose register, stack pointer, program counter, timing control circuit, interrupt circuit, everything. So in microcontroller, we have all the things are on the single chip. In microprocessor, we have the bit manipulations also, means we can, in microprocessor, we have only 1 or 2 bit manipulation instructions, means single bit can be handled only 1 or 2 by 2 instructions. But in microcontroller, we have so many bit manipulation instructions also. In microprocessor, we have less number of multi-function pins, but in microcontroller, we have the more multifunction pins also. So as we know that design is flexible. Flexibility is always there in the case of microprocessor, but design is very less flexible in the case of microcontroller. Microprocessors are expensive and microcontrollers are cheap as compared to microprocessor, due to the everything is on the chip. In microprocessor, we have instructions to move the data between the memory and CPU. Many instructions. But in microcontroller, we have only 1 or 2 instructions to move the data between the memory and CPU. And the accessing time, that is speed, we can say, is access time for memory and input output devices are more in case of microprocessor. Means speed is slow because everything is attached. But in case of microcontroller, access time is less due to the inbuilt memory and input output devices. So these were some of the differences between the microprocessor and microcontroller. So with this, we have completed this topic also. Further, we will start with the next chapter, that is your programming and assembly language programming. 8051 assembly language programming. In this chapter, we will discuss the various registers, RAM, ROM, in case of 8051 in detail. Okay. Students, I am going to start with the next chapter, that is second chapter, and the name of the chapter is here 8051 assembly language programming. In this chapter, I will demonstrate some of the registers used in the 8051 with simple instructions move and add. Move instructions for using for the copying the data from one register to the another, and add instruction is used for the addition purpose. And also we will do the assembly language and machine language programming, and different terms of your mnemonics, opcode, operand. Then how we can write our program and create the program and execute our program. Then what is the flag bits used in 8051? All then which type of registers banks are available? All these concepts will be discussed in this chapter. Now going further, firstly I will start with the 8051 registers. Now going to the next slide. Now that is here inside the 8051 registers. Actually, in the CPU, the registers are actually used to store the information temporarily. And the information can be of here byte. So we can use the or access the byte or process the byte, 1 byte at a time. Or so actually the vast of the majority of the 8051 registers are of here 8-bit registers. And the 8 bits of the registers means it can handle only and only one data type, that is 8-bit. Means if you are having the 16-bit data, then we have to divide that data in the form of your bytes, and 1 byte at a time will be handled. Now in the next slide you can see this is the 8-bit data D0 to D7, where D0 is known as LSB, that is least significant bit, and D7 is known as your most significant bit. So if any data larger than 8-bit is there, it must be broken into 8-bit chunks before it is to be processed. Actually, we know that there are a large number of registers in 8051. Firstly, we will concentrate on some of the widely used general purpose registers. Then I will discuss the special registers also. Next slide, the most widely used registers are accumulator, that is responsible for all the arithmetic and logical operations. Arithmetic means like addition, subtraction, multiplication, division. These all are the arithmetic operations. Whereas logical operations contains the or, and, not, XOR, all the logical functions. So most widely used registers are A, B, R0, R1, R2, R3, R4, R5, R6, R7. Along with, we are also having the widely used registers as DPTR. DPTR full form is data pointer. And the second one widely used register is your PC, that is program counter. Actually, all the registers A, B, R0, R1, R2, R3, R4, R5, R6, R7, all are the 8 bits except the DPTR and PC. The accumulator actually register A is used for all the arithmetic and logical operations. For understanding these, all the basic registers, we will use two instructions, move and add. DPTR is further divided into two parts. First is your DPH, second is DPL. DPH stands for data pointer high byte and DPL stands for your data pointer low byte. As you know that if you are having the more than 8-bit data, then we must divide that data or broken that data in the 8-bit chunks. So if DPTR is your 16-bit register, then 2 bytes will be there. A byte will contain 8 bits. DPH high byte, DPL low byte, data pointer low byte. Next is move instructions. All these register operations can be easily understood by the two instructions. One is your move instruction and second one is your add instruction. Now the move instruction. Now you can see move destination comma source. This is the syntax for writing the move instruction. Move destination comma source. So what is the function of this? The function of this command is to not to move. Actually, we have not to move. We should copy. Actually, this instruction will copy the data from source to the destination. So the source operand will be copied to the destination operand. There are three terms: opcode, operand, and mnemonics. Opcode tells us, operation code tells us what the function should be performed, like move. And operand is the data on which we have to operate our operation. And mnemonics means in any language we will write or operation of any operation on any instruction is given by a mnemonic in the short form. That is like MOV, that is mnemonic. ADD, add, that is mnemonic, which is the signifies that what type of operation is performed. This indicates this is the language, programming language. Now, as you can see in the first command, move a comma hash. This hash sign signifies that 55H is a value. That means that is the data. What does it? This instruction will do 55H. H means hexadecimal. As you know, in the digital electronics, you read that there are 4 types of number system: decimal, binary, hexa, octal. If H is written, then it will be hexadecimal number. If nothing is written with the data, then it will be definitely your decimal. So, but H is written, so 55H. What the instruction will do? The 55H data is to be copied or loaded into the A accumulator register. Means destination is here, accumulator, source is 55, direct data is given. Next command is move R0, A. That is copy the contents of A into R0. Next, as you know, R0 is a register, R1 is also register, R2 is also register, R3 is also register. So move R1, A. Accumulator contents is moved to the or copied into the R1. That is A. As you can see, this is A is equal to R0 is equal to R1. That is 55H. Similarly, we can also copy the data into the R2 with the command move R2, A. Next is move R3, hash 95H. That is 95 data is to be copied into the R3 register. Now move A, R3. What does this instruction tells? This instruction tells us that copy the content of R3 into the accumulator register. So after this instruction is executed, the destination register is updated with that value. So and the hash sign indicates that it is a value. While doing the programming in 8051 microcontroller, some of the points should be noted, some of the points should be kept in mind. First point is that value can be loaded directly into the register A, B, R0 to R7. It indicates actually hash 55H indicates actually its immediate value will preceded with the pound sign. That is hash. Now further you can see move A, hash 23H. This will load the 23 hexadecimal number into the accumulator. So A will be updated as 23H. Similarly, move R0, hash 12H. Move R1, hash 1FH. Move R2, hash 2BH. You know that in hexa, 10 is written as A, 11 is written as B, 12 is written as C, 13 is written as D, 14 is E, and 15 is F. Now move R1, hash 1FH, move R2, hash 2BH, move B, hash 3CH, move R7, hash 90H, and the destination register will be updated with that content. Next is move R5, hash 0F9H. As you can see from the above, this instruction is somewhat different. 0F9H. So notice in this instruction, move R5, hash 0F9H, that there is a need for 0 between the hash and F. It indicates, by putting the 0, it indicates that F is a hex number, not a letter. Because you know that F can be treated as letter, as an alphabetic letter. But if I want to show that this is the hex number, not an alphabetic letter, so put the 0 between the hash and F. If you are not putting 0, then this command will cause an error. Means if you write move R5, hash F9H, then this will be cause an error. Now the next is second observation in this. Now the move R6, hash 12. This is the decimal number, but R6 contains the 0C. Why 0C? C is 12. Decimal equivalent of your hexa. Decimal equivalent, 12 is equivalent in the hexa is as a C. So we can simply not written as move R6 comma hash CH. That will be wrong. C will be treated as where alphabetic letter. If this is a hexadecimal number, so put 0 in front of that. So hash 0CH. So this will 0CH will be copied into the R6 register. So if value 0 to F are to be moved into the 8-bit register, the rest of the bits all should be 0. Means you can see if I am only moving the 12, that is C. So put the 0. That is H. Or you can say if I have a command move A comma hash 5, it means A will be equal to here 0 5, not 5, it will be 0 5 because 8-bit data. Next, third point which should be kept in mind during the programming part, that moving a value that is too large into a register will cause an error. So I have discussed all these points. You can see first point was value can be loaded with the preceded with the pound sign. Then add a 0, indicate 0 in front of F. Then single digit will be written as where 0 5. And next point to be kept in mind is moving a value that is too large into a register will cause an error. That is if move A comma hash 7F2 H, you can know, you know that it is an 8-bit, processor, but we are giving the 3 bits, that is 7F2. That means this is the 12-bit. In binary, it will be one digit, one hexa digit will be written in binary as a 4-bit. So 7 is 0 1 1, F is 4 times 1, and 2 is 0 0 1 0. So 12 bits data is there. But you know that cumulator is here, can handle only up to FFH, that is 8 bits data. But this is the 12-bit data. So it will cause an error. In another example, we can also like move R2 comma 456. This is also illegal because in 8-bit maximum number is 2 raised to power 8 is 256. That is 0 to 255. Only 255. We can only store 255 decimal number into R2. But if we are giving as a 456 and so on, then this will be the illegal procedure. This will be the illegal operation and it will cause an error. Now, next point is should be kept in mind that to load a value into a register, we have to put a hash sign, pound sign. But if I want that if I will not put this sign, then 23H will be treated as memory location, not the data, not the 8-bit data. Means with hash sign, pound sign, it will become data. Without pound sign or hash sign, it will become as memory location. Means if I am writing in this instruction as move a comma 23h, it means that the data stored in the memory location 23h should be copied into the register cumulator. So it means it will be treated now as your memory location. Actually, if we are not putting the pound sign, then it will not cause an error. But this is also a valid instruction. But now it will be treated as your memory location, not the data. In that case, only and only result would not be what the programmer intended. So result would not be correct in that case. But without hash sign, instruction is possible. In the next lecture, we will understand the add instruction. Till then, take care and we will meet in the next lecture. Thank you.